in case it's a little too early, the talk we're having right now is HTTP IDS evasions revisited. I'm Dan Roelker, and I guess we'll get started now a little bit. You may be asking yourself, who is this guy? Well, just a quick background on what I've done. Currently, I work at SourceFire Incorporated, basically the corporation behind Snort now. I came on board with Mark Norton to redesign the Snort engine for high-speed networks. We came on board, did that in about 2 months, and you guys might have seen that in the release of Snort 2.0 in September-October timeframe. What I did after that basically is working on some protocol decoders for Snort, most notably probably a new HTTP decoder that's going to be coming out in the next month or two, but don't quote me on that. So, I've been working on a couple of those things. Before that, I was also lead developer on the Dragon IDS. I did, again, like some application protocol decoders and high-speed packet capture, event correlation with Randy Taylor. So, I've kind of been working with application protocol decoders for a couple years now, 2-3 years. So I want to kind of give some of the knowledge I've learned over the last couple years and bring it over to you guys. How many of you in the audience are actually involved with IDS, either in developing IDSs, employing IDSs, managing IDSs? How many people in here? All right. How many of you guys actually compare the differences between the IDSs, try out different tests? And all right, good. Well, I hope you'll be able to take some information away with you today with some tools that I'll be releasing after the talk. They're actually probably on the DEF CON website now, or if you want to, you can download the most recent versions at idsresearch.org. You may be asking yourself who these strange-looking people in the front row seats are. Well, they work at SourceFire too, but they have free Snort T-shirts available for people afterwards. So if you want to, talk to some of these guys up here, these three, why don't you raise your hands? If you didn't bring any Snort T-shirts, I'm sure they could, you give them your name and mailing address. I'm sure they can send you some. So anyway, just wanted to plug that. So hopefully my expenses will now be paid. So before we begin, anyone with a laptop or maybe just a really great memory, what we may want to do here is pull up, if you're running Linux, do a man ASCII to pull up an ASCII map. A lot of the URL encodings that we're going to be doing, and it's going to be easier for you to reference what we're encoding and all that kind of stuff. So if you do have something available, if you're just running Windows and you trust the DEF CON wireless networks, then you can Google for like an ASCII map as well and pull that stuff up. So once we actually start going through the different URL encoding types, we'll, I think you'll find that pretty handy. Go through a quick presentation outline here. We're going to talk a little bit about the history on HTTP IDS evasions. Why were they important? What tools were developed that kind of started this all out? We're going to talk a little bit about evolution of the IDS and HTTP evasions. We're going to look at both, probably the two main types of IDSs: protocol analysis IDSs, pattern matching IDSs, where they started to, how they evolved with HTTP evasions, and where they are now, and where does that actually leave HTTP evasions currently. Then we're going to talk about two general types of application layer evasions. I want to kind of talk about the general types because I'm hoping that, for one, they're easier to understand than some of the more detailed applications we're going to talk about. But also, if you understand these general types of application layer evasion, you'll be able to do your own IDS evasions, look at protocols yourself, try and figure out how you can mangle some of the different options there. So we're going to talk about these two, and the two we're going to discuss in this presentation is invalid protocol parsing, which is anyone familiar with the tool Sidestep by Robert Graham? A couple people. Well, basically that tool helped bring about this type of application layer evasion. Basically works like, if you can fool the IDS into thinking that a certain protocol field is like something else, then you've effectively evaded the IDS. So like, for example, if you're parsing the HTTP protocol and you think the HTTP version is actually the URL, then you're not going to decode it correctly and you're not going to be able to match on malicious URLs. The second type we're going to talk about is invalid protocol field decoding. This means basically, like, even if you parse the protocol field correctly, if you don't know what data is actually in that protocol field, then you won't be able to find what you're looking for. For instance, if you're looking at the SNMP protocol and you don't really understand ASN1 encoding, then you're not going to be able to match certain things. Same thing with the URL. If you just do a basic hex encoding on the whole thing, but you're expecting to see plain text, like you're expecting to see CGI and PHF, but instead you're seeing like percent, this, percent that, you're not going to be able to detect it. So that's the general types of application layer evasion that we're going to talk about. Then we're going to go through the two types and talk about practical applications. For the protocol field decoding, we're going to talk about 9 types of URL encoding. We're going to start out pretty easy with the hex encoding and just get a little more complex. Pretty much all these URL encodings, except for two of the encodings are valid on both Apache and IIS, but the rest are really thanks to Microsoft. And so a lot of those, it kind of adds a little more complexity into that. So we're going to go through all those, give you some examples. Hopefully you'll be able to take away from the talk all these different types of encodings. But if you're still a little hungover from last night, you can always look at the tools I'm releasing because they cover all these encodings as well. So you'll have a little help with that. From there, we're going to move into the invalid protocol parsing. We're going to talk about some new evasions like request pipeline evasions, how that works, and we're going to talk about some parameter content encoding evasions. For those things where you're accessing like the database and you have some malicious parameters, or you're trying to exploit some CGI errors again in the parameter field. You want to make sure that the IDS can't see that if you're trying to evade it. So we're going to, this evasion really goes through and helps you with that. And then after that, it's basically tool time. We'll talk about the different tools that are being released with this talk. So I guess let's get us started here. A little history on HTTP IDS evasions. Web attacks are some of the most common and effective attacks in the matrix. Yeah, I know Trinity used an SSH exploit to shut down the emergency power grid, but trust me, these are web attacks come in all forms and sizes. You just don't have to wait around for your favorite web server to come out with a buffer overflow for someone to discover that. Lots of different ways you can do it. You got CGI errors, you got database hacking, got a lot of different ways you can handle this, cross-site scripting attacks, all that kind of stuff. So web attacks, not only do like companies, governments, banks, they all have some sort of web server available, and so these are really some of the most common and effective attacks that you can do. And because of this, IDSs really, really, really want to catch these things because, otherwise they look kind of foolish if they go into bake-offs and someone runs a, web attack that they should catch, but hey, guess what, I didn't. Most of the web attacks, if you've been noticing recently, when they come out, it takes about 2 days before it gets turned into a worm that shuts the internet down for a couple hours. So, we want to make sure we can catch those things. Okay, now we're going to talk about a little bit of the tools that help bring about HTTP IDS evasions. Can never get through this talk without mentioning Whisker. This was perhaps the first and most effective web scanner that employed IDS evasion techniques. I think there's about 10 or so. When Whisker was released with the IDS evasions, it really shut down some IDS companies. They were really scrambling to catch the same old attacks they had always caught before. I did a little work with Dragon to help with that. And it's just a lot of the IDS vendors really had to catch up with that. The Whisker IDS really played off, and I want to make this distinction between Whisker and Sidestep. Whisker really played off of either web server quirks or quirks within the IDS's HTTP decoders. For instance, like one of the Whisker attacks is that you basically embed like a capital HTTP / version in the URL. That was done in hopes that the IDS would look just for that string HTTP / and then say, okay, well, I found that, so I think the URL is here. That falls kind of into the invalid protocol parsing evasion we had, I discussed a little bit earlier. But a lot of the other ones also just had to do with web quirks. Like for instance, Apache would accept a tab instead of a space as well to separate the GET request and the URL and the HTTP version. So they're very effective attacks, but they're much different than the tool Sidestep. And I bring up Sidestep here, even though it's not known for web attacks or HTTP evasions. When the tool was released, it really brought about a very good idea and a very influential idea in how to evade IDSs. Basically, Robert Graham used the application protocols against the IDSs. It wasn't working off of quirks or the actual protocol decoders themselves in the IDS, but it actually really delved into the application layer protocol and exploited, I guess I could say that, with some of the lesser known characteristics of that protocol. The two types of evasions we're going to talk about really kind of stem from the Sidestep type of evasion. Basically, we got the request pipeline and the parameter encoding, and they really come from this because they're utilizing aspects of the HTTP protocol. Let's see here. So basically moving on. Evolution of IDS and HTTP evasions. And we'll start from the beginning here. You basically have two different types of IDSs, main ones anyway. You got the kind that tout protocol analysis will catch your attack, and you got the kind that say pattern matching will detect detect what you want to. At the beginning, they behaved kind of similar before any evasions came out. For instance, URLs at that time weren't encoded with any type of encoding, so the protocol analysis IDSs would work by parsing the protocol, finding the URL, and then doing some pattern matching to look for malicious URLs. Whereas the pattern matching IDSs just like search the whole payload to see if there are any malicious URL contents anywhere in the payload. However, when the evasions did come out, there was a stark contrast between the two. The protocol analysis IDSs were one step ahead because all of a sudden they had already been parsing the protocol, so all they had to do was implement the encoding algorithms to decode those encodings correctly. Whereas pattern matching IDSs actually had to now write a protocol decoder for the protocol being evaded, then had to implement the encoding methodologies. And once that was done and given a couple years, the two again converged and they behave very similarly now. So that means that since they behave similarly, we'll be able to use the types of evasions I'm discussing here against both types. Current state of IDS, HTTP evasions. Where's the technology now? It's been kind of stagnant for a couple years. What does that mean for the evasions we're going to talk about? It means basically we can use these against both different types of IDSs. So, just kind of keep that in mind. These should work against, to give you some specific examples, like, you could use them against Real Secure, Snort, Dragon, any of the other open source IDSs as well. So, all right, so we're going to talk a little bit more now about the two general types of application layer evading. Invalid protocol parsing. Like I said, that stems from sidestep, and it really comes from the fact that most IDSs, they're not exactly pros in protocol analysis. What you do for this type of evasion is really research an application protocol. Look for areas of the protocol that you think are a little obscure, and test it out against your IDS, see if it actually interprets those correctly. These are very effective evasions because it's not trivially fixed. Basically, if one of these comes out, a lot of times IDSs have to completely redesign and re-implement the protocol decoder because there's some fundamental flaws in their parsing algorithm. So these are very effective. The invalid protocol field decoding, it's like I said before, it's basically, even though an IDS parses that field, finds the field correctly, if it doesn't know the data that's there, then it can't interpret it correctly. For instance, one of the things we'll be talking about is what happens when you do a post request and you encode the post payload with base64 encoding. Does your IDS go down to the payload, decode that using a base64 algorithm, and then match against it? Probably not. So that's how the protocol field decoding works. They're both very effective. However, the invalid protocol parsing is probably the more serious of the two because those really, in general, means some kind of redesign on the IDS's protocol decoder. All right, so now we get into the more practical application side of this. If you haven't got that ASCII map out in front of you, don't worry, I'm going to be helping you out a little bit with this. But so we're going to talk about this. We're going to try and get through these URL encodings. Hopefully, I'm going to try and go through them fairly quickly because they're not the most exciting things for me to talk about or for you to listen to. So hopefully, you'll be able to get the main gist from the presentation. And again, given what I'm going to bring up in this talk, you should have the tools to go do additional research on your own in the web and know what to look for and tools to try out, things like that. So we'll start out right now, I guess. First one we're going to start out simple and then get more and more complex, is your good old hex encoding. It's been around for years. It's been an HTTP standard for years. Most IDSs all handle this, and most web servers all handle this as well. So this is pretty much a universal encoding. Is it that effective against IDSs? Not at all. But I want to start here because some of the later encodings we're going to talk about utilize this type of encoding. So basically, the concept behind this is you look up in your ASCII map the character you want to encode. You look up the hexadecimal value, not the octal or the decimal, but the hexadecimal. And so, for example, what we're going to probably be using throughout this presentation is the capital letter A. The hexadecimal value for that is 41. So how hex encoding works is in the URL, you escape it with a percent, and then you put the characters 4 and 1. So when that gets sent over to the web server or an IDS intercepts that, it sees the percent 41, knows what to do with it, and decodes that into a capital letter A. Pay attention a little bit to this encoding, though, because we are, like I said, going to use it through probably the next 4 different types of encoding. So, you guys should probably be familiar with this, especially those of you that, are more in the IDS field. Next one we're going to talk about here is the double percent hex encoding. You probably saw this with some of the bug tracks that came out about it a couple years ago. Basically, this is the same as the normal hex encoding, except you're encoding the percent first, and then you follow that percent by the values, the hexadecimal values of the bytes you want to encode. So, for example, if you got that ASCII map out in front of you, you look up percent, its hexadecimal value is 25. So in order to regularly hex encode that, you do a percent 25. You then follow that by the bytes you want to encode. So in this case, A, again, the hexadecimal value is 41. So you got percent 2541. And thanks to Microsoft IDS, you got a double decode. So it goes through it once and then goes through it again. So as you see on the first pass, the percent 25 gets then turned into a percent, and then on the second pass, the percent 41 gets turned into an A. Okay, double nibble hex encoding. Again, this was working on Microsoft IDS. Basically how this works is each hexadecimal nibble of the byte we want to encode is itself encoded using the normal hex encoding method. How many of you wanted to wonder how many encodings I could get in one sentence? All right. So basically what that means is, to go back to our example with the A, we basically got the hexadecimal 41. So in order to encode this using the double nibble hex encoding, we look up 4 in the ASCII map. Its hexadecimal value is 34. We look up the 1. Its hexadecimal value is 31. And we encode those using the normal hex encoding. So percent 34 and percent 31. And we make sure we put that other percent right out in front of it, so on the second pass, it'll pick that up. So on the first pass, the percent 34 gets turned back into the 4, 31 to the 1, which leaves us with percent 41, and then percent 41 turns into A. Okay, first nibble hex encoding. Anyone want to guess what web server? That's right, Microsoft IDS. This encoding is very similar to the double nibble encoding, except the only difference is only the first nibble is encoded. So in this case, the first nibble of A is a 4, so we encode that with the percent 34, and just leave the 1 as 1. So you get the percent 34 1, which turns in, first pass, percent 34 turns into 4, leaves with percent 41, which by now hopefully everyone knows that percent 41 turns into A. All right. Second nibble hex encoding, IDS. Just like the last one we talked about, except the second nibble is encoded. And the first one's just left alone. So we got the percent 4 and then the percent 31, because the 1, the hexadecimal value for that's 31. On the first pass, the 31 turns into a 1, leaving percent 41, which leaves that. Okay, quick break encoding. I'm just going to try and make a joke here, break it up a little bit. So anyway, guess I didn't go over so well. Anyway, but we got about 4 more URL encodings to go. Gets a little worse now before it gets better. After these encodings, then we're going to go into the invalid protocol parsings, which are a little more, a little easier to understand, and not so much into the bits and the bytes. Okay, UTF-8 encoding. I'm going to try and go through this fairly quickly. If this is the first time you've heard of UTF-8 or tried to decode it yourself, you're probably not going to get all of it in this presentation, but go to unicode.org, things like that, and you'll be able to learn more about it if you're interested. Basically, UTF-8 is a way to encode values that are greater than a single byte value of 255. So UTF-8, most web servers will accept up to values of 64K, 65,535. We're going to talk about 2 UTF-8 byte sequences here. The 2-byte sequence. How the UTF-8 encoding works is that the first byte in the sequence contains the high order bits contain the number of bytes for the whole sequence. So as you see in the 2-byte sequence, the first 2 high bits are set followed by a 0. What that tells the algorithm is this is a 2-byte sequence. The bits after the 0, are part of the value of what we're going to be decoding. And then with the extension byte after that has a high bit set followed by a 0, so you have 6 more bits. You add those together, you get 11 bits total, which a 2-byte UTF-8 sequence will give you a max hexadecimal value of hex 7FF. 3-byte sequence, very similar. Again, you basically got the 3 bits, 1, 2, 3. That tells you it's a 3-byte sequence followed by a 0. So you got 4 bits in the first one, 6 bits in the second, 6 bits in the third. So together that gives you 16 bits for a max hexadecimal value of FFFF. And the final showdown here. UTF-8 encoding is supported by both the Apache and IIS web servers. Kind of breaking out of the mold here, not just IIS, but getting Apache in there. And just wanted to let you guys know the new UTF-8 and Unicode standards don't really allow you to encode ASCII characters in multi-byte UTF-8 sequences. The current versions of Apache now follow this, but IIS still, I don't think, does. So we're going to do a quick example here. Again, this is going to be our example of A, which turns into hexadecimal value 41. So what this looks like first in UTF-8 is %C1, %81. Remember, anytime you want to encode an ASCII character in a URL, you got to usually escape it with a %. So in this case, the C1 turns into, as you see here, the first byte there, the second byte there. And if you go one more, basically I'm Xing out the bits that are for the UTF-8 encoding, so you know what to do, which leaves us then with the 100001, which is a hexadecimal value of 41, which equals A. I know that's pretty fast, but if you're really that interested in Unicode UTF-8, you can Google your heart out. All right, back to Microsoft IIS again. Remember how I told you had to escape bytes with %? Well, guess what? You really don't have to do that with Microsoft. Well, all you really have to do is send the byte. So, for example, the UTF-8 sequence we just talked about, which was C181, all you do is you send the byte C1 followed by the byte 81, okay? And IIS will interpret that. What makes it kind of cool as well is that you can encode the first byte with a %. So you could send like %C1, and then you could send just the bare byte 81. A lot of IDSs don't really mix and match these things, so we'll get to a mismatch encoding a little bit later. But that's something to keep in mind, because when you mix these encodings up, it really works well against different IDSs. All right, %U encoding. We're almost done with the encodings. What this is basically Microsoft's little way of encoding Unicode code points of up to 64K. Basically, its syntax is %U followed by 4 bytes, which is 4 bytes, which equal basically 4 nibbles or 2 bytes. How you kind of encode that is you actually put the Unicode value. So, for example, if we want to do A, its value is hexadecimal 41. You put zeros in front of that, and you end up with a 41 there. Don't get confused. I've seen a lot of people do this. Like they see for example, like we did the UTF-8 encoding with C181. A lot of people say, oh, well, that's the code point for A, so I'll just put C181 in here. So you'll have like %U C181. That's wrong. What you really put in here is the actual Unicode value, which this is very effective against Microsoft, because what they've done for us is with a certain Unicode code page, an ASCII character, say A, may map to like 8 different Unicode values. So you'll have like the value of 41, 100, 102, 104, etc. So you can actually just put that in there. So like the same encoding, %U0041 equals A, you could also do like %U0100 also equals A, or %U0102 also equals A. So you get a lot of those. You can thank Microsoft for that, because given, if you have a different code page as well, the ASCII characters map to different code points, so it's, it's pretty convoluted. And now we're on the last encoding. This is actually the most interesting one, because it's, as I said a little bit before, the mismatch encoding really, what it does is we take the other 8 encodings we just talked about and put them together, So basically, at the end here, you can see I got a little quiz for anyone that's interested. You can write that down. That translates to 1 letter. So, give it your best shot and see what you can translate it down to. And, if you want to double check with me afterwards or whatever, just come up and, ask me. But, yeah, so mismatch encodings, they're very effective against IDSs, and just, most IDS analysts, even if they catch the packet, you think they could decode that? Probably not. So, anyway, just keep that in mind. All right, so we're done with the encodings now. We're on to the invalid protocol parsing, practical applications. To me, these are actually the more interesting IDS evasion types because they're a little more general. I think a lot of people can understand them, and they're very, very effective against IDSs. If your IDS doesn't catch it, then they're pretty much going to have to really think about how they want to redesign the protocol decoder. So we're going to talk about two types that I mentioned previously, the request pipeline evasions and the parameter content encoding evasions. And both of these, like I said, are pretty effective. Request pipeline. So what is a request pipeline? Anyone know? Raise your hand if you know request pipeline, anyone? Okay, well, basically it's a new feature in HTTP 1.1. It basically allows your web client to send multiple requests in a single packet. This is different from the keep alive option because with the keep alive you could send a request with the keep alive header and the web server will keep that connection over, then open, so then you can send another request like a couple minutes later. This is different because you actually send the request in the same packet. So as we look at that, it's actually very effective in evading IDSs. How does it work? Well, most IDSs, they only assume that one HTTP request packet is going to contain one URL. But with request pipeline evasions, that's not the case anymore. You can put as many in there as you want to. So how does this work then? For the first couple URL requests, we say, okay, we'll send some pretty benign requests. Like we'll look at the / the index. We'll look at the content. We'll maybe download the logo, GIF, or whatever we want to do. And then the last URL request, you basically put the malicious URL you want to access. If you leave it in plain text, it's probably not going to work for you because a lot of IDSs at this point, what they do is just do pattern matching still over the whole packet for certain malicious contents. So what you want to do is just encode that last malicious URL with your favorite type of encoding. Hex encoding works just fine, and it's universal for all web servers. So you kind of encode it like that, and most IDSs won't ever decode that URL. So here's kind of an example here. As you see, we got the benign request. Always remember when you're doing request pipeline, you have to have the HTTP 1.1 version, and because of that, you always have to have the host header because that's mandatory in the HTTP 1.1 protocol. So if you don't put the host in there, odds are the web server is going to say, I don't know what you're talking about. So remember to put the host parameter in there. So as you see, we just access the index, the content.html, and then we basically encode our last one. If an IDS happens to be looking for the content CGI bin PHF, they're not going to find it there. Instead, they'll just see a bunch of percents. So, and that's what that encoding turns into is CGI bin PHF, and you can access things like that. Okay. Parameter content encoding evasions. This evasion is particularly effective when you're doing any sort of parameter type malicious parameters. If you're doing database hacking, you're putting in some select statements that aren't really that good, like select all credit card numbers or whatever, things like that. You want to make sure, if you're trying to evade an IDS, that that's not in plain text. This also works well for again, CGI input errors with the parameters at the end, or if you find an unpatched IIS server, there's still some out there. You can use your command.exe with the parameter types. So how does this one work? Well, instead of doing a GET request and putting the parameters after the question mark and encoding that with whatever URL encoding you want to do, because most IDSs decode the URL and the parameter URL field too, so you can't really get away with that anymore. What you do now is you actually change that GET request into a POST request, and you put the parameters down after the header section into the HTTP payload. So we've moved the parameters now into the payload, but again, it's still in plain text. So an IDS most likely is going to find that malicious content that it's looking for. So we make it a little tougher by using the content encoding header in the POST request and picking your favorite type of encoding. Like you could either zip it or you could base64 encode it or whatever you want to do, and then run your parameters through base64 encoding, on whatever you want to do there, and then putting that into the payload. So what an IDS now has to do is say, okay, this is a POST request. What type of encoding is it using? And then it goes down to the end of the payload and decodes that. IDSs just don't do that because right now it'd be very time-consuming and lead to potential DOS attacks against that. Because there's a lot of valid POST traffic, and it's a little scary. So this is what it would kind of look like here. You got the POST CGI bin PHF. Again, people see that PHF and say, oh, it's an attack. But say, for example, you're accessing like a database like Oracle. You can't really write a signature for Oracle database access because there's a lot of valid traffic going across there. So you'll just get a lot of false positives. So if you're actually accessing a valid resource on the web, you're not going to be able to really detect this attack. So as you see, we basically set the content encoding, base 64, we set the content length as 15, and then the parameter sections to CGI bin PHF, for an example, Q alias, whatever you want to do. So, again, IDS will be looking for Q alias. It's not going to find it there in the base 64 encoding. All right, so that's kind of the more formal part of this talk. Now we're going to talk a little bit about the different tools that there's available for you guys to use. Basically, there's three different ones. An encoder.c, this is going to do all the different encodings we just talked about, and this is a command line version. Runs on both Windows and Starnix, whatever you want to do, Linux, BSD, whatever. And then we got HTTP Chameleon, which was written by Mark Norton, my colleague. He basically wrapped up the functionality in encoder.c with a really nice Windows GUI. So it's okay. I don't, just because you use the GUI doesn't mean you're less elite than anyone else. But I actually find it pretty useful because it's a little, keeps a lot of the history around, keeps a lot of different templates that you can use, and hopefully it'll make it a lot more accessible to everyone. And then the final one we got is the Microsoft Unicode map.c. What that basically does is you run that on your Windows box, your IIS server, whatever you want to do, and it dumps all the code pages and the code points that's on your system. Maybe just for your information, if you kind of want to know what code pages your system's using, this will also be very useful when the new Snort HTTP decoder comes out, because the new configuration allows you to specify certain code pages and code points for individual HTTP servers, so you can make sure you can catch the specific attacks. For instance, to kind of give you an example about this, a lot of people try to decode Unicode code points to Chinese web servers, IIS web servers, using like the American code point mappings, and that doesn't work because like they have a different A equals different code points on the Chinese web server. So if I don't know if any of you guys you're administering or watching different web servers, like say in Hungary or China, America, it's good to know this because a lot of IDSs, all they do is default to the American code page, and it's wrong. So just wanted to bring that up. So we'll talk a little bit now about the tools. Start off with encoder.c. This is a command line tool, allows very fine-grained encoding of HTTP URLs. You can encode like each character in a different type of encoding you want. You can throw in directory traversals, multiple slashes, backslashes, whatever you want to do. Also, in case you don't have like Netcat on your machine to pipe what this prints out across the wire, there is some simple socket support built in, so you can just port this program over and you'll be able to do some research on the web servers or do some IDS testing. And I would suggest, though, if you do run Windows or like Windows, use the HTTP Chameleon instead. It's a lot more useful, as you'll see, because I'll do a little demonstration here in a little bit. Okay, encoder.c usage. Basically, you got your three different ways you can encode text. You can encode a single character by just doing /A with a character, or the encoding type. /A and encoder.c happens to be ASCII encoding or hex encoding. If you want to encode a whole string, you basically just put the string in the braces there. And if you want to do like a code point that's outside the range of a normal ASCII character, like say you want to encode like 1FF or something, you just kind of put that in there to the code point. Remember, this kind of is like C syntax, so if you're using a hexadecimal value, put a 0 lowercase x in front of that value to designate that it's actually a hex encoding. Okay, HTTP Chameleon, written by a colleague, Mark Norton, with the Windows GUI. I think it's much more usable, and I guess we'll do a quick demonstration here with it so you guys can kind of check this out. Okay, this is pretty much what the GUI looks like here. As you can see, got an about box, a help box. The help's actually pretty advanced, so download this at your leisure and go ahead and read different things. It kind of gives you some quick starts, how to use different things, save some templates for yourself. It also explains the different types of encodings here. And like for example, first nibble is /I, etc., things like that. How it kind of works is this way. We'll take the basic Unicode attack, years old. We'll select that one. Kind of comes down here, and this is the basic attack. it's basically a template. So you can decide how you want to encode this one. So for example, you could say, okay, scripts. I think many IDSs will be able to find that, and that shouldn't be normal access. So we could do like a short UTF-8 encoding. So we'll double click that. Pops up what I highlighted. I didn't highlight the whole scripts, just a little bit of it. And then it, click OK, and it puts in the encoding for that. Then, for example, then we got WinNT System 32. Let's maybe encode that a little bit, obscure it up a bit. Maybe use double hex encoding for that. Double click on there. Comes up, you click OK, puts that one in there too. Then a command.exe, you definitely don't want that in there. So you do this one and maybe do a mismatch encoding on that. And we'll do the, say OK, fine. All right, so you kind of have that. And then once you're ready, then you click encode, and up comes your encoded URL here. So anyone want to try and read that out for me now? All right. So basically, you got all that, and you're hoping now at this point that your IDS actually can encode and decode that. So now you basically put in your HTTP host, and you can send the request. The HTTP response spits out what you got back, so you can tell if it was successful or not. It's kind of interesting, try it out against like your home web or like some of your test web servers or whatever to see what you can get. So it kind of works like that. The other thing that's kind of nice is, let's see here. For example, if you do this and get this up here, Unicode Explorer, I think it still has some problems with the XP here that I'm running, which, by the way, this is my wife's laptop. The company I work with couldn't give me, I guess they didn't have any laptops available, so, it's mad props to GW Law. So, but basically, you got a couple different things here, and see if this will come up here. Sometimes not. Oh, no. But, so we got this. Now I want to explain, oh, not responding. Oh, I just rooted my box. I'm cool. So let's see here. Okay, wait, Unicode Explorer. So basically what this does here is you got your code pages you can select. These are all the code pages that are currently on XP. You got, for example, Latin 1 is what is the default on all American servers. So click that one. And basically now you can go ahead and pick your favorite character you want to encode. Remember I was talking about those different values for A? Well, there you go. Not only do you got 0x41, but you got like, 6 other ones or whatever. So, feel free to pick it and, you pick one here, comes up. And then, you basically have like a reference as well. You can say, well, what other code pages in the system also refer to code point 0102 as A. So you can kind of scroll down here and say, oh, okay, cool. So, so you basically got that. I wanted to also just kind of give you an idea here for the request pipeline. Clear these out here. Basically, here we go. I'll actually encode it first because it's a little easier to read. As you see here, we got the first URL request, normal. We got the second logo.gif. And we got the third CGI bin PHF. Well, remember I was telling you don't leave that CGI bin PHF in prints there. So basically we're just going to take it all and highlight it. Wait, I don't want that space there. There we go. And then we say, I'll just do a simple hex encoding on this. Okay, looks good. Click OK. Then encode it. So we're back here. Everything looks the same except CGI bin PHF's gone. So that's kind of the idea behind it, all right? So like I said, play around with it. Send us, if you find something not working or you have some troubles with something. We're probably going to be releasing a new version of it that fix some of the problems in the next week or two. So feel free to check back at idsresearch.org for the latest. So let's see here. So back to the slideshow, and we're almost done at this point. All right, so the MS Unicode map.c, this basically, like you saw in the Unicode Explorer that eventually came up, it basically just tells you what the different code pages are and the code points. And slide 37, and we're done. Maybe a little early, but thanks for being a great audience and not heckling too much. Download the updated tools at idsresearch.org. and I may be releasing some code for basically you'll scan a web server and go through and tell you what types of encodings work on that web server, so you can test out, make your IDS testing a little easier. So, all right, so questions, anyone? I got one right up here. Yep, good job. All right. Nice.
You were talking about the base-64 encoding,
Uh-huh.
and then some of the IDS was good because of performance reasons.
Yeah.
The HTTP decoder, the new one,
Right. I guess we'll have to find out. I can't really talk too much about it, so sorry didn't tell me to, to talk too much about it. It should be coming out though in the next couple months. So, it's gone through some pretty rigorous testing, so we'll give it a shot. And the question here?
In a lot of cases, encoding is not something that you would see. And how much are you looking at doing signatures for encoding as opposed to signatures for what? I mean, in base-64, it'd be silly to drop the base-64 into processing encoding there. But it's easy enough to tell someone's base-64 encoding, and odds are that's going to be unusual in most cases.
Okay, question was basically instead of actually decoding the URL, could you just basically try and detect that encoding's been used? It's a good question. You definitely can do that. The only problem with that is that you really won't be able to get the attack that was sent. You'll get the alert that says, hey, this URL was encoded, but unless you're like a decoding expert on URLs, you probably aren't going to know what actual exploit was brought about. So, we actually want to try and do those decodings if we can. Okay, question over here.
If you're capturing this and you're running into something like a
Yeah.
how successful is it against some of the multiple encodings?
Oh, how's Etherreel up against that? Okay, basically the question was, say you capture some of this traffic with Etherreel. Etherreel doesn't decode URLs. So you're kind of up on your own. Yeah, exactly. Yeah. So, okay, next question. Right there in front.
also works over HTTPS, up to this tool, making it able to do HTTPS.
Okay, question was, do these encodings work across HTTPS, and is there any way that we're going to maybe change the HTTP chameleon tool and to support that? Yeah, we may in the future, and yeah, they definitely work over that. Anyone know what time it is? I want to make sure I'm not going over time. What is it? Oh, okay, so we got some time. All right, more questions? This one down here. Yeah, that's actually it deprecates some of the double decodings for IS, but not the Unicode code points. So, again, if your IDS doesn't know the different, values for the Unicode code points, then you'll be evaded that way. But yeah, that's a good question. By the way, the question was, if you use URL scan for the IS web server, does it help you with some of the decodings and not make them all available? And it does not make them all available. Question in the back there, I thought we had. Yeah. I haven't tested against that, so I don't know. He had asked, does the EI web scanner stuff work with this? I'm not sure. Yeah, URL scan with IIS actually does deprecate certain double decodings, so it kind of just leaves you up with the hex encoding, the %U encoding, the UTF-8 encoding, the bare byte encoding, and all the multiple Unicode code points you can encode. Question down here again? Oh, okay, in the tool? Okay, the question was, if you find a really messed up encoded URL, could you paste it into the tool and it'll spit out what it was? Not at this point, but that is a feature we'd like to add. So, okay, question there too? I'm not sure. I'm not an expert on configuring IIS, and Apache you probably could, I'm pretty sure, but I'm not sure about IIS. Okay, question over here again. Trying to get both sides of the room. Yeah, actually there is, because say you're trying to access a URL that with a HTML, you're trying to access a web page that's Arabic characters. The only way you can do that with the URL is actually encode it using the valid UTF-8 encoding. So for example, or Hungarian as well, if you're trying to use some of the letters that aren't in the American alphabet or that are actually Unicode code points, you would have to encode those certain ones in the URL to access it correctly. Does that answer your question?
feedback in my route. So walking the URL.
Yeah, he's wondering like if he's not really too worried about the decodings and code point encodings, then yeah, you can definitely block those at the router, or however you want to do that. Try your best. Question there? What is it? Oh, okay. Question was, have I tested this out against OpenBSD firewall the normalization with that? No, I haven't. I doubt they incorporate this though. So, but yeah, I'm not really sure on that. Okay, question over on this side.
What about browser recognition of encoded HTML structures like things like that?
I'm sorry, I didn't really hear you.
What about browser recognition of encoded HTML structures, bracket tags, things like that?
Okay. What about them?
How well do most browsers handle these kinds of encoding?
Oh, the browsers actually, like when you get sent back, usually the browsers will be able to handle Unicode encoding. I haven't really tested much out against if I actually send all these different types of encodings to a browser. I've been more server-based, but I'm not really sure. You're welcome to test that out, though. Okay, question here. Yeah, it definitely is a flag. He had asked, are all these different encodings, like if you see them across the wire, aren't these things you want to alert on anyway? Yeah, they are definitely things you want to alert on. But in the same way, an IDS really should decode these things as well, so like what's been accessed. Otherwise, like if you see something like, let's see here. Oh, I don't have it up anymore. But like, if you see something like that CGI bin PHF string encoded, you're going to have no idea probably like what actually was accessed, and was it a valid URL on your server even, or were you compromised? So, but yeah, okay. More questions? Okay, one more after this last question, so go ahead. These encodings aren't exploits in and of themselves. These are really IDS evasions. The only solution to these are actually for your IDS to be smart enough to handle all these things. Otherwise, you're probably not going to be able to handle these correctly, or even detect them, or anything like that. So, yeah, and which should be out fairly shortly. Okay, last question. I'll see if anyone from this side, because I've been answering a lot from this side. All right then, right here. What did I already ask? Well, let me get this guy because he's a new one. Go for it. They already do. Yeah, Apache. They already support Unicode encodings. So, yes, in URLs. Yeah. But remember, they only use the UTF-8 standard that we had talked about. Not like the %U and all that stuff. All right, so that ends the question and answers. Thanks a lot, people, for coming out. If you want to talk to me afterwards, just come by. Thanks a lot. All right.